Have you ever wondered how the data is stored in your computer? In the world of digital information, everything we interact with, from pictures and documents to software and games, all reside within a marvelous piece of technology called a hard disk drive, or HDD for short. These unsung heroes of the computing world hold a significant role in data storage, tirelessly working behind the scenes to ensure our digital life runs smoothly. Whether you're exploring the realm of computer science or simply intrigued by the inner workings of your computer, understanding how these hard disk drives function can be quite rewarding. It's like peering into the heart of your digital world, where all your precious memories and important documents are kept safe and sound. So what really goes on inside these data storage powerhouses? How does a hard disk drive store such a vast amount of information? Now you might be curious, what's inside these hard disk drives? Let's open one up and find out. Inside a hard disk drive, you'll find a complex assembly of components. Each of these parts plays a crucial role in the process of data storage and retrieval. Let's take a closer look at these components. First up, we have the platters. These are the heart of the hard disk drive. They are circular disks made up of a substrate and a magnetic medium, the latter of which is responsible for storing your data. Now, these platters aren't just sitting idle. They're spinning at a speed anywhere from 5,400 to 15,000 revolutions per minute, depending on the model of your hard disk drive. Next, let's talk about the read-write heads. These are tiny sensors that hover just above the surface of the platters. When you're saving data to the hard drive, the write head changes the magnetic orientation of the particles on the platter, effectively writing the data. When you're retrieving data, the read head detects these magnetic orientations and translates them back into the data that your computer can understand. The read-write heads are attached to an actuator arm. This arm swings the read-write heads across the surface of the platters, allowing them to access different parts of the disk. It's a bit like the arm of a record player if you're familiar with those. Now, you might be wondering, how do the platters spin? Well, that's the job of the spindle. The spindle is a motor that spins the platters at a consistent speed, ensuring that the read-write heads can accurately access the data stored on the platters. And finally, we have the actuator. The actuator is a device that moves the actuator arm, allowing the read-write heads to reach different tracks on the platters. It's like the conductor of an orchestra, guiding other components to perform their tasks at the right time and in the right place. So to sum it up, the platters hold the data, the read-write heads write and read the data, the actuator arm moves the heads to the right location, the spindle spins the platters, and the actuator controls the movement of the arm. It's a beautifully orchestrated dance of technology, all happening inside that small hard disk drive in your computer. But let's not forget the unsung heroes, the electronics that control all these components. There's a whole circuit board on the bottom of the hard drive that sends commands to the actuator, translates the signals from the read head into data your computer can understand, and even corrects errors when they occur. So these are the components that work together to store your data. But how exactly does that happen? Well, that's a story for the next part of our journey into the world of hard disk drives. Stay tuned. When you save a file on your computer, it gets written on the hard disk drive. This is a process that might seem simple, but it's a symphony of precision and engineering taking place at a microscopic level. Let's delve into it. Writing to a hard disk drive, or HDD, is an intricate dance between several key components. The main players in this dance are the platters, the actuator arm, and the read-write heads. The platters are the shiny circular disks inside the drive. They're coated with a magnetic material and spin at high speeds. The data is stored on these platters in the form of tiny magnetized sectors. The actuator arm is a thin piece of metal that stretches over the platters. At the end of this arm are the read-write heads, which are like the needle on a record player but far more sensitive and precise. These heads hover just above the platters, without ever physically touching them. Now, when you hit save on a document or download a new song, your computer sends the data to be saved to the hard drive controller. The controller translates this data into a binary format, a series of ones and zeros that the drive can understand. The actuator arm then swings into action. The hard drive controller directs the actuator arm to the correct position over the spinning platters. It's a bit like a high-speed, high-precision game of darts, where the dartboard is spinning at thousands of revolutions per minute, and the dart is a stream of binary data. The read-write heads at the end of the actuator arm then take over. They flip the magnetization of the tiny sectors on the platters, turning them north or south to represent the ones and zeros of the binary data. North might represent a 1 and south a 0, for example. This process happens incredibly quickly. Modern hard drives can write data at speeds of up to hundreds of megabytes per second. That's like writing the entire contents of a novel in the blink of an eye. It's important to note that the data isn't written in one continuous line, but rather in concentric circles, or tracks, on the platter. The tracks are then divided into sectors, each of which holds a certain amount of data. The hard drive controller keeps an index of where each piece of data is stored, so it can be found again when needed. This is similar to how a librarian keeps a record of where each book is in a library. And there you have it, a whirlwind tour of how data is written to a hard disk drive. It's a process that combines precision engineering, high-speed movement, and a dash of magnetism. That's how data is written on a hard disk drive, but how is it retrieved when you need it? We'll explore that in the next scene, so stay tuned. Retrieving data from a hard disk drive is just as fascinating as writing it. Imagine a library filled with countless books. Now imagine a librarian who knows precisely where every single book is and can retrieve it in an instant. That's kind of how a hard disk drive reads data. The process begins with the read-write heads. These are tiny electromagnets that float just above the surface of the hard drive platters, moving rapidly back and forth as they scan for the required data. Remember, we're talking about distances smaller than a human hair here, so precision is absolutely critical. Now here's where things get magnetic, literally. We've previously discussed how data is written to the hard drive by changing the orientation of magnetic fields on the platters. When it comes to reading data, the process is essentially the reverse. As the read-write heads move over these magnetic fields, they detect the changes in orientation. This generates a small electrical signal, which the hard drive's control electronics interpret as binary code. This binary code, a series of ones and zeros, is what all data on a computer ultimately boils down to. It could be part of a text document, an image file, a piece of music, a video, or any other type of data. The computer's processor then takes this binary code and translates it into something we can understand, like the words you're hearing right now. So, in essence, when you open a file, the hard drive's read-write heads zip to the right location on the platters, detect the magnetic fields, generate an electrical signal, and send that signal to the processor, all in the blink of an eye. Of course, this process can vary slightly depending on the specific type of hard drive and the data it's reading. But the basic principles remain the same. And that, in a nutshell, is how a hard disk drive reads data. That's how data is read from a hard disk drive. But with so much data to store, how do hard disk drives manage to fit it all in? Hard disk drives have an amazing ability to fit more and more data in the same physical space. This ability is largely due to the concept of bit density, which refers to the number of bits that can be stored in a given area. As technology advances, hard disk drives have been able to increase their bit density, fitting more data into the same physical space. One technique that has significantly increased bit density is perpendicular recording. This method organizes data vertically, rather than horizontally, allowing for much more data to be stored in the same area. Another important advancement is shingled magnetic recording. This technique overlaps tracks of data, similar to the way shingles on a roof overlap, again increasing the amount of data that can be stored in the same area. That's the marvel of hard disk drive technology, always evolving to store more and more of your data. The future of hard disk drives is even more exciting. Let's dive into the latest advances in HDD technology that are promising to further increase the data storage capacity of hard disk drives. Two of the most cutting-edge technologies in the HDD landscape are heat-assisted magnetic recording, or HAMR for short, and two-dimensional magnetic recording, often referred to as TDMR. Heat-assisted magnetic recording is a technology that heats up the recording surface of the disk platter before data is written onto it. This heating process allows for the data to be written in a much smaller area, ultimately leading to a significantly higher storage density. In essence, HAMR is allowing us to cram even more data into the same physical space. On the other hand, two-dimensional magnetic recording takes a slightly different approach. Instead of focusing on writing data in a smaller area, TDMR is all about reading data more accurately. It uses multiple read heads that work in unison to read data from the disk surface. This allows for more accurate data retrieval, especially when the data bits are packed closely together. TDMR is like having multiple pairs of eyes reading the same page, ensuring no word is missed or misinterpreted, no matter how small the print. These technologies are not just theoretical concepts, but are actively being developed and implemented by major hard disk manufacturers. In fact, they are expected to be the next big leap in hard disk technology, potentially increasing storage capacities by several orders of magnitude. And while we're talking about the future, let's not forget about solid-state drives or SSDs. These devices use flash memory to store data, and while they currently offer less storage capacity than HDDs, their speed and reliability are unmatched. As SSD technology continues to evolve, we may see a shift in the balance of power in the data storage world. So that's how the hard disk drives in your computers work, from the basic components to the cutting-edge technology. It's a fascinating world of data storage, isn't it?